Now that you've learned about quadratic functions in vertex form and standard form, and you know the parameters of both of those different forms, it's time for us to do something with them. So in this video, we're going to learn how to graph our quadratics, specifically when we're in vertex form. Quick recap, vertex form is f of x, or y if you prefer, equals a times x minus p squared plus q. And each of those three parameters, if you remember correctly, all had some sort of effect on our graph. So we have a, p, and q. And if we look at each of them, a did two things. It controls the width, so it determined whether our graph was skinny or wide, and it also controlled the direction of opening, so it decided whether our graph opened upwards or downwards. P moved the graph left and right, or just horizontally. And then Q is a lot like P, but instead of moving the graph horizontally, it moves the graph vertically. And if we're graphing in vertex form, all three of those parameters are going to help us draw our graph. One thing to look out for before we go any further, remember, this is x minus p, not x plus p. So that's going to affect our values, and we have to be really careful with that. It's by far the most common mistake in this unit. So if we're going to draw graphs with these, we've got two options. This video is going to cover the more step-by-step way. There will be a second video that you can choose to watch, which involves a shortcut. The shortcut is faster, but it does involve a little bit more deep thinking. So you'll have the choice to do whichever option you feel most comfortable with. For this option, we're going with method 1, which is going to be a table of values. You've done table of values before. You've probably been doing them since elementary school at this point, so hopefully they'll be fairly comfortable for you. So let's get a function going that we can work with. We'll use the function y equals 2 times x minus 2 squared minus 1. So looking at this, before we go any further, it's probably a good bet to decide what our a value is, what our p value is, and what our q value is. So here, a is this 2 out front. So we've got a is 2. P, this is the tricky part. Remember, it's x minus 2, just like it was x minus p up above. So that means that p isn't negative 2. P is positive 2. Again, by far the most common mistake. And then q, down at the end here, is negative 1, because this is minus 1 when it should be plus q. So those three values, 2, 2, and negative 1, are all going to be really helpful for us when we draw our graph. So that was step 1. Step 1 is determine a, p, and q. Step 2, which will be fairly straightforward based on what we have, is to find out where the vertex is. Thankfully, we don't actually have to do any work from that, because if you remember your last lesson, our vertex just comes from p and q. And we already know what p and q are. So all we have to do is take those two values that we had, which are up here, so p and q, and those give us our vertex, which is 2, negative 1. So now we know what our vertex is. That means that we already know one point of our graph before we actually do anything else. So let's make our table. That's step 3, is make a table of values. You may also, if you have trouble remembering what a table value is, you might remember it as a t-chart. So we've got our x values on the left and our y values on the right. And here's an important note for you. Always, always, always put your vertex in the middle. Because if you remember what a parabola looks like, the vertex is always in the middle of the parabola. So if we're making a table and we're finding points, we should also do the same. So that means we've got 2, -1 right there in the middle of the table. Once you've done that, then we want to find points on both sides of the vertex. So for us, since our vertex is at 2, that means we're going to want to find x equals 3, x equals 4, x equals 1, and x equals 0. Those 5 points are going to give us enough to do a parabola. You can technically do it with 3, but it's not really good enough. It's the same as trying to draw a line with 2 points. If you mess up, the whole thing goes off. So generally 5 is our go-to number. To find our values, all we do is we take these numbers that we've chosen, we plug them into our function. So we've got, going back up, y equals 2 times x minus 2 squared minus 1. That was the function we're working with. Copy it back down here. And we're just going to take each of those x values that we chose, and we're going to substitute them in for x in our function. So this x right here is just going to get replaced with each of these 5 values in turn. We don't have to do the 2 because we already know it, so we'll just do with the others. Let's start with the easiest option, which is 0. So we'll plug x equals 0 in. So we've got y equals 2, and then so this x is now 0. And then minus 2 squared and minus 1. And so to get our y value, all we do is do the calculations here. So 2 is just 2, 0 minus 2 is -2. Then we'll square that and subtract 1. Be really careful, make sure you're following BEDMAS here. So next up, we need to do our exponents. -2 squared is 4. Multiplication comes before subtraction, so 2 times 4 is 8. And then 8 minus 1 is 7. So that tells us that when x equals 0, going back up to our table, y is 7. Perfect. So we've got one of our values. Now we do the exact same thing, except we're going to do it with 1. We'll go a little bit faster this time. I'm not going to show you all of the steps. So we replace the x with 1 now. So 1 minus 2 is -1. -1 squared is +1, and so if we multiply that by 2, we just get 2. And 2 minus 1 is 1. So that's our next value. When x is 1, y is also going to be 1. And so here is by far the most important thing. If you remember back when we were learning about parabolas, if we look at this little example that I really roughly sketched here, remember, parabolas had an axis of symmetry that went through the middle, and that's because parabolas are symmetric. So if we have a point on the right here, it's going to have a mirrored point on the left. Every point in the parabola has a mirrored point on the other side, which makes graphing them a lot easier because instead of having to find 5 points, we really only have to find 3, because these points here, which are the same distance away from the vertex, right, we've got a distance of 1 here and a distance of 1 here, they're going to be mirrors of each other because of symmetry. So since x is 1, y is 1 is one of our points, when we go down to 3, y is also going to be 1. And we can make the same connection between 0 and 4. So these 2 points are both 2 away from our vertex, right? Our vertex is in the middle. So since this point up at the top here is 7, this one down at the bottom here is also going to have a y value of 7. So we've got our table of values after only finding a couple of points. So to tidy that up a bit, we'll re-sketch it out down here. We've got x and y. Our vertex in the middle was at 2, -1, and so we had 0 and 7, 1 and 1, and then 3 and 1, so again, mirroring across the vertex, and then 4 and 7. And there we are. We have 5 points. So let's draw ourselves a graph. Most of the time, generally, you're going to want to go either 5 in every direction or 10 in every direction. Looking at this one, we can maybe cut a corner a bit though. The lowest we get is -1 in our y's. The highest we get is 7. So let's just sketch ourselves out a grid. Try to use a ruler if you're sketching these for yourselves. Unlike me, you don't have something that just draws straight lines for you. And we can see our x values are on the positive side of things, so we maybe don't need to go quite as far to the left. I'm just going to stretch this a little bit further. All right, so just going over some basics of drawing grids. Remember, you want to label your axes, so we've got x and y. You also want to put arrows at the ends of each of your axes. And then you want to put your numbers. So 1, 2, 3, 4, 5, 6, 7. And going to the negatives on the left. And positive is up and negative is down on the y-axis. So let's plot our points. Our vertex was at 2, -1. You generally want to start with that point. Then we also had points at 1 and 1, and 0 and 7, and then 3 and 1, and 4 and 7. And so remember, we see this symmetry. I'll erase this in a sec, but we've got this axis of symmetry going down the middle here, and you can see our points are mirrored from each other. So we got a distance of 1 there, distance of 1 here, distance of 2, distance of 2. So the axis of symmetry splits our line into, or our parabola into 2 mirrored halves. Now we want to put a line through it. So remember, thinking back to what I put in the last video, there's no point at the bottom. It doesn't curve randomly off to the side. It doesn't have any straight lines. It doesn't go straight up and down. So our parabola, they're not easy to draw. You'll probably see me have to do a couple of takes here. But we just want sort of a gentle curve, flattens out at the bottom, again, not into a point, and then curves back upwards, something like this. I'm not expecting perfection from any of you. It's hard to do by hand, especially when you haven't practiced it. You can see mine's not very good. But that's at least a general parabolic shape. So do your best and see what you can come up with. So we'll try one more of these. I'll give you another function and you'll see if you can graph it on your own. And then I'll give you the answers in a sec. So our next function is going to be y equals negative x plus 4 squared minus, actually we'll say plus 5. There we go. So start by figuring out where your vertex is, make yourself a table of values, and then sketch your graph. Pause here. Once you're done, come back and then see how you did. Alright, so you've hopefully drawn your graph at this point. So let's see how you did on things. Our vertex, if we look at this, so remember A is the number out front here, and you might not see a coefficient out front, so you might think, oh, I don't know what A is. But if there's no number there, the number is always 1. Or in this case, since there's a negative, it's -1. Our p-value is right here, but again, you have to be really careful. It should be x minus p. So since that's a plus 4, it's actually x minus -4. And then q down at the end there is positive 5. So we have our a, we have our p, we have our q. Those two give us our vertex. And so our vertex is at -4 and positive 5. Otherwise, we're just going to make a table of values, we're going to make ourselves a graph, and we'll see how it goes. So first things first, our table, we've got x, we've got y. We put our vertex in the middle, so that was -4 and 5. As I mentioned, we want 2 points on either side, so we're going to go with -3 and -2, and then also -5 and -6. Keep in mind, again, that these points are going to be mirrored with each other, so we only actually have to deal with 2 of them. Generally, you want to go with the easier numbers, so we'll probably go with -2 and -3 and see how it goes. So we got x equals -2. Our function, which we had up there, was y equals negative times x plus 4 squared plus 1. So let's plug -2 in there and see what we get. Be really careful with your negatives here. So we've got negative times -2 plus 4, so that's negative. That'll be +2 squared and then plus 5. 2 squared is 4, so we've got -4 and then plus 5. And then -4 plus 5 is +1. So when we have -2, we end up with +1, which also means, because of symmetry, -6 down here is also going to be +1. I'm not going to show all the work, but for -3, we're going to get 4, which means we're also going to get 4 for -5 because of symmetry. So those are our 5 points. Let's draw ourselves a graph. Okay, so I've got my axes here. Again, I'm going to remember to put arrows, and I'm going to label my numbers. So something to keep in mind here, if you're looking at your parameters, remember what A does. So A did 2 things. It controls the width, and it also controls the direction of opening. And so if you remember back to when you were investigating all this with Desmos, you found out that if A is negative, the graph goes down. So looking at this one, since A is negative, our graph should go downwards if we've done things correctly. So let's find out. We had -4, +5. That's 1 point right there. We had -3, 4, and -5, 4. And then we had -2, 1, and -6, 1. So seems like it opens downwards. I'd say we've done a pretty good job. So let's sketch ourselves a parabola here. Once again, not looking for perfection, just do your best. And one thing to note, remember to always put arrows on the ends of your parabola to show that it keeps going, because it doesn't cut off where you cut off. That's a choice that you've made, not that the math makes. All right, so take a look at this, compare to what you did. If you didn't quite get it, go back over your notes, look at your numbers, maybe rewatch the video, and if you're still having help, make sure you ask. Otherwise, take a look at the next video to see how to draw this the shortcut way.